but we're going to have to do something just to get it on video. So I'm assuming there's questions on probably the last 3 problems. Changed my mind. Probably on the test there's only going to be 1 problem, 1 word problem instead of 2. And it's going to be like either 6, 8, or 9. So are we doing all of those? Because the others are pretty basic, right? Otherwise ask tomorrow, because let's see if we can. Now I'm assuming writing the function is the hard part. I'm assuming you guys can graph it on your calculator. Oh, that's a bad assumption. Okay. Okay, number 6, I gave you a picture. Here's a raft, and you have to get to the snack bar over here. And this is 50 meters. Okay, and this is 100 meters here. The lifeguard can swim 2 miles an hour and run 6 miles an hour. So express the total swimming and running time as a function of x. Because, you know, if you can run way faster than you can swim, you're not going to just swim straight to the snack bar, right? You're probably going to run somewhere over here, swim, and then run the rest of the way, yeah? So this is x, so wouldn't that make this 100 minus x? So since rate times time equal distance, time is equal to distance over rate. So right here you have a right triangle. If this is x and 50, wouldn't this be the square root of x squared plus 50 squared using the Pythagorean theorem? So the total time would be the time spent swimming plus the time that you spent running, right? So what's the time that you spent swimming? It would be the distance, which is this, divided by the rate. How fast can you swim? What does it say? 2 miles an hour. And then here's the distance that you run, which is this, and then you divide by the rate, which is 6, right? So the time spent swimming plus the time spent running will give you the total time. So just punch this in on your calculator, and then you should have like a hump again. Set the window, calculate the minimum, right? And then you can figure out where you should aim so that you can get to the snack bar in the shortest amount of time, yeah? Okay, number 8. I think I gave this one, did I give it last year or 2 years ago? A cone circumscribes a sphere, so it's on the outside. I'm just going to draw a side view. I'm not going to even attempt to draw 3 dimensions though. Okay, so the cone is outside the sphere. And the cone and the radius is 1. Now, how do I draw in the radius of the sphere to help me do this problem? Yeah, you draw it to the point of tangency because it forms a right angle. Anytime you have a circle, come on, this is like SAT, right? And a tangent line, you draw it to the point of tangency because it forms a right angle. Express the volume of the cone as a function of the base radius r. So here's the radius of the cone. Here's the height. Okay, what's the formula for a volume of a cone? 1/3 pi r squared h. Okay, here's h. So what we have to do is we have to write the height h as a function of r, so we can just put it in here and we can graph it on our calculator. Okay, but how do I figure out what h is? Similar triangles. Okay, which 2 triangles are similar? The big one, the Papa Bear, and this one right here, the Mama Bear. Except it's like different orientation, right? So you gotta kind of have to flip it over. Anyway, if you have a hard time with similar triangles, draw them separately. Okay, here's the Papa Bear, and here's the Mama Bear. Now in the Papa Bear, this is R and H, right? Now in the Mama Bear, well, what's the radius of the sphere? Do we know what the radius of the sphere is? Isn't it 1? So in the Mama Bear, that's 1. So how do I figure out what this is? Well, there's lots of things you can do. Like once you get r and h, you can use the Pythagorean theorem here and go h squared plus r squared. Okay, but once you know this is 1 in the Mama Bear, you got to flip it over like this. you either gotta figure out this side or that side so you can set up a proportion. So which one are we gonna go with? Which one looks easier? Look, if it's h from here to here, and this is 1 here, what does it make from here to here? Wouldn't that be h minus 1, which is the hypotenuse over there? So you want to just go with that then? Yes, in the interest of time we are. So setting up a proportion, this over this, hypotenuse over short leg equals hypotenuse over short leg. So hypotenuse over short leg equals hypotenuse over short leg. That is your proportion. And then what you need to do is you need to solve for h in this equation so you can plug it in here. Okay, I'm going to just leave it. You guys try it tonight. If you still can't get it tomorrow, then write it on the board. Okay, but last year I gave this problem on the test, except I changed the 1 to a 2, and all hell broke loose. So this year, change it to a 3. Okay, finally, we've got 2 minutes. Can I finish this last one? Let's see, 9. A can is, okay, I think we can write this. A can in the shape of a right circle, it's a cylinder. Dumbo, just wasted time. Cylinder has a volume of 1, and it's, okay, why don't we call this R and H? Use the graphing, okay, we want to minimize the cost. Okay, so how do you figure out cost? Okay, you have a circle on the bottom and a circle on the top. What is that? 2 pi r squared. And how much does it cost to make the top and the bottom? What does it say? The material costs 80 cents per square foot. Oh, so even the sides cost. What's the area of the side? 2 pi r h, right? So that's the total surface area of the can, and it costs 80 cents per square foot. So you got to multiply it by 0.8. But there's other costs involved. Like when you actually build a can, you have this thing like this. You make it into a thing like that, right? And then you have a top and the bottom. But how do you keep the top and the bottom on without falling off? You solder it. So you get a solder gun, which is basically you're melting metal, and you're going to get and because if you're holding peaches in there and you don't have anything to keep it in, the thing is going to leak out, right? So you have to solder it. Okay, so how much does solder cost? 20 cents per foot. So how much did you pay for solder? That's 1 circumference. That's 2 pi r. That's another circumference, another 2 pi r. And then h. So that's how much you have to solder, and solder costs 20 cents per foot. I think 3 years ago I gave this problem. I just changed that to 75 cents and changed that to 15 cents. All hell broke loose. Now you can't punch this in on your calculator because you got 2 variables, so you need another equation. It says the volume of this can is to be 1 cubic foot. So pi r squared h is equal to 1. Solve for h in this equation. Take that and plug it in here and there, and now you can punch it in on your calculator. So try that now. If it doesn't come out, write it on the board tomorrow. Tomorrow we got to do a lot of stuff. We're in a heap of trouble. That's quiz 2. Hey, tomorrow's going to be a big day.